Looking for a mic check, testing 1, 2, clarity and volume. Okay, so I guess we're on right now. All right, cool. So when thanks everybody, thanks welcome to the stream. My name is Curtis. I'm an instructor at Coincident Constraint in Sacramento, California, and I teach a few classes there. I teach the Circuit Playground Express class. I teach a intro to soldering for electronics. I teach a TV design for laser cutting class. And I've also been doing Livestream on Tangential Constraint and some free classes that we've been offering related to Tangential Constraint, specifically for 3D printing. A little quiet and a little bubble times. Change that. And hopefully this will be a little bit better. Testing audio 1, 2. All right. So again, I'm an instructor, Capital. Tonight's class or live stream will be focused on Fusion 360 sketch constraints and other sketch-related functionality that may not be part of our intro curriculum. So with that, I'm just going to kind of demonstrate different constraints in the sketch mode, talk through those, and I'll occasionally look to Niall, who is at Hacker Lab, to give me kind of feedback on it. My audio is okay, can you hear everything, can you see everything correctly? And so that will be kind of the format tonight. Hopefully you'll get some nuggets of wisdom out of this. But constraints are sometimes very hard to kind of get into a class because they're each and every one's a little bit different. And it takes some experimentation to get used to. So that's kind of what I'm just going to do tonight. So I'm just going to experiment and have you here with me. Let's go along for the ride. Okay. So I'm actually in Fusion 360 right now. I'm going to go ahead and get rid of these objects. And I'm going to go ahead and just create a sketch. You can create a sketch a couple different ways. You can go up to the create menu that I've highlighted here with my cursor, and you can say create sketch. Or you can hit the S key and then start to type in the word sketch, and we'll populate that with a couple of different selections, and create sketch is the one that I want. Once I select that, the Fusion 360 interface asks me to tell it what plane I want to sketch upon. In this case, for 3D printing, the best practice is to sketch upon the XY plane, which is the green-red plane, or the plane that straddles the green and red axes. So I'll go ahead and click on that plane. And then the tool kind of sets itself up to kind of look at that, those two axes edge on. And so up here we have the view cube up in the upper right-hand corner. I can grab the view cube and I can just kind of drag it around. Excuse me. And you can see the different effect that has on the XY plane, kind of putting in the skew. And when we print, we usually print on when we 3D print, we usually print on a 3D printing bed. In this case, the bed, this approximates the bed, and then your object would build out upward into the Z-axis, which you can see here on the view cube extending out in this direction, which is perpendicular to the X and Y axis. So for the sketch, I'm going to go back to looking straight down at it. And we have to reset the view cube. The view cube right now says that this is the front view. I actually want this to be the top view. So I'm going to right click the view cube and set current view as top. Now you see my view cube indicates it's top. I'm looking down upon the XY axis. I'm looking down through the Z axis, if you will. All right, so what are constraints? Constraints are various features of CAD that let you set your drawings up to behave or to kind of act in a certain way. I guess behave is the same word, just said it differently, the same way twice. So what we can do are constraints, some example of the constraints, and now we want to kind of freeform on this. I'm just going to actually get the constraint tool, and you get a big list of constraints right here that you can select from. I'll just kind of quickly flip through these and read the description, and then we'll kind of experiment with these. So horizontal vertical constraints, a line or 2 points to lie on either the vertical or horizontal axis, whichever is closer to the current alignment, so snap to that. So the instance here is I can create a line, so I'm in sketch mode. I'm going to also now click the line tool, and the line tool lets me start define a beginning and end for my line. And so I'm going to just click here and extend out, and notice I'm maintaining the angle to not deviate from that horizontal line. And then I'll just click another time, and that sets my line. Okay. Now this line, this characteristic, this constraint, this horizontal constraint is set up so this line can do, you can make it longer or shorter, you can move it around its position, but it will always be horizontal. So if I select it, I can move it to left and right, I can grab it in, and I can extend it. But if I try to grab that end and move it up or down, like I was doing before, and that would change the angle, now the line moves up and down because it's constrained to be a horizontal line. So the entire line can move. All right. Same thing goes with vertical. It's just instead of on the x-axis, it's to be on the y-axis. And so I can set that kind of a line up. And this vertical line is now constrained. And you can see the constraint is indicated by this small icon. This here indicates a horizontal constraint. This here indicates a vertical constraint. All right. Let's see, what else can I demonstrate here? Let me make a square, or a rectangle rather. And you'll see that as soon as I set that rectangle and I set the last point and it creates the rectangle, it automatically defaults to adding those constraints. And you'll notice this line here is a vertical line, and then we have a horizontal line and a horizontal line. And we can change the box, right, the rectangle. We can change the dimensions. We can change the position. But it's always going to have 2 horizontal elements and 2 vertical elements. And once an object is fully constrained, that is to say, constrained to the point where it can no longer be moved, modified, scaled, rotated, what have you, that's called a fully constrained sketch or sketch object. So in this case, even though we've said that these lines have to be horizontal and these lines have to be vertical, it can still, it's the design of this can still change based on what you do by either expanding or scaling or what have you. So if I wanted to do something like make this square, not just rectangular, but square, then I'd have to do something where I'd have to make the sides equal to each other. So we can try that out. I'm going to click on this line, get rid of it. It's not my way. And so let's see, there is an equals constraint up here. So if I drop down, we first started to look at the horizontal vertical constraint. Now we're going to be talking about the equal constraint. And so if I make, if I click the equal constraint and I click this line and I click this line, now you can see it adds another constraint type to the sketch here and here. That means those two lines will be equal to each other. So I can still make changes to this object, both scale and position wise. And so I've constrained it more, but I can still can move it around. So let me add one more constraint. I'm going to equal constraint this side to this side. So now three of these sides are forced to be equal to each other. So let's see what kind of effect that has. So I can still move it around and I can scale it. So it's not quite fully constrained yet. So let me add that last equal. I want to make this side and this side equal. And it tells me it's over constrained. So why is that over constrained? All right, let me try another set. This side and this side. No, doesn't like that. And doesn't like that. Maybe because of the size I started with. Let me start by creating a perfectly square object. And then I will make these two sides equals to each other. Over constrained. I can try that again. These sides equal to each other. Yes, it only lets me do two. Alright, so let's see the effect that has on the sketch. Yeah, I can still move it around and I can scale it around. So now let's see if this side is equal to this side. This has to be vertical, these have to be vertical, these two have to be horizontal. Then how else can I constrain this? I guess I could try the dimensioning tool. So while we're in the CAD design tool set, we have a dimensioning tool which is up here. You can select it from the menu. You could also hit D to go directly into the dimensioning tool. You can see my pointer icon has changed. And up here, you can see it's highlighted now like it's selected. An alternative way to do that would be to click the S key, which brings up the search shortcuts. And then I can click D, start to type in dimension. Then sketch dimension pops up. I can click that. And I can say I want to dimension those two lines. And I want to dimension it at 75. Now I think it's close to fully constrained, but I can still move it. So now I can't scale it. I can't really rotate it because it's forced to be vertical and horizontal lines. Two of the walls have to be equal to each other, and the third wall is actually dimensioned 275 millimeters. So all of those things are kind of blocked. And where's switch? I'm not sure the switch one is. Yeah, well, I can switch too. So now, but I can still move the whole square around. Move it that way. Oops. We can move it around like this. So now the last thing we need to do is kind of anchor this point, if you will, or this point, to something that we can anchor to. And in this case, we have the midpoint of our axes. You can never say that right. So I can say something like I want to use the coincident constraint. And if we look at our constraints here, the second one down is coincident. This constrains the position of 2 points or a point in a line or a curve together. So this could be a point constrained along the line, 2 points constrained to each other, or a point constrained along a curve. In this case, we want 2 points constrained to each other. We want that corner point of our square constrained to the center point of this array, or this graph area that we have, our workspace. So let me do that. Let me click on coincident. It now wants me to choose the two objects I'm going to make coincidental. And so that would be the center point here and that point there. And you see it automatically snaps those two items together, and I have an old object here I'm going to delete because it was from what I started with, but it's a little bit in the way. So now I don't know if you noticed all the colors of this sketch here have turned to black. And that means that, and you also notice that there is a small red padlock icon that appears next to the sketch item up in the browser. And so that tells you the sketch is now fully constrained, and that has significance in that, now if you accidentally enter in a number or something differently, that your design will be retained. You're not asked, and the attributes of the design will be retained. All right, so something else I want to point out is that, this was a dimensioning tool that we used here, and we actually, kind of manually typed in 75 millimeters. But there's a way that we can create parameters or modify variables that we can then represent these values in. So if we want to kind of copy this information elsewhere. So here, if I go to change parameter, this is in modify. Go to change parameters. And we'll link it out a little bit here. How do I add my parameter? You know what? Let me finish my sketch and see if I can do it this way. Okay. I'm going to add a user parameter of length and expression. No, I may not be able to show that. All right, I got to scroll myself up a little bit more on parameters. All right, so that was the coincident. The coincident constraint allowed us to set this sketch up so it's locked to the center point. It is locked to have both vertical and horizontal lines, and three of the sides have to equal this side, which is then dimensioned with a variable, or excuse me, dimensioned with a value that we've entered. Yeah, well, let me try to get sneaky on it. Okay, so we've already talked about now the first two constraints. So now we'll talk about tangent. So tangents largely have to do with circles or curves. And the constraint, oops, sorry, let me just go ahead and actually back up one step. Excuse me. Finish that, and I'm going to create a new sketch for this item. So again, I'm going to create sketch from the create menu, or I can click S to pull up the search and then start to type in sketch and create sketch and go that way as well. I think I just quickly clicked on the plane, so it just quickly snapped in there. All right, so what I want to demonstrate now is the tangent constraint. And like I was saying before, it typically has to do with some kind of circle or curve. And here we have a circle and a line. And the tangent, what it will do is it places the edge of this circle on this line and forces it to be on this line. No matter where it is on this line, whether it's even part of the line that's visible or not, because this ray, this line, if you will, kind of extends in either direction in your imagination, kind of infinity. Right? You know that's going to kind of go back to here, and kind of pass up and kind of continue on and on and on. So when we set a tangential constraint, it can be anything along that ray. It doesn't have to just be along the line that I have highlighted here. So you can see the tangent is kind of demonstrating the concept visually. Constrains a curve and another object so they touch at a single point but never cross each other. Maybe I didn't highlight the never cross each other aspect of it, but it's really just, it rides this edge of this circle will ride anywhere on this line. So let's go ahead and take a look at what that looks like. I'm going to click the tangent constraint. I'm going to click the edge of the circle, and it already assumed that I had that line. I think maybe I had it highlighted, and it actually connects these two lines. Now it's not fully constrained, and if I take my select tool and I move it around, both the line and the circle can change position depending on what I'm doing. And also you'll notice it can't extend out here because that ray, that line, if you will, kind of extends beyond the visual indication that we're being shown. So that is a tangential constraint. If I make the circle bigger or smaller, it remains in force. And I can also pull the circle. Let's see how to do that. I thought there was a way I could get it to flip over to the other side, but you get the idea. All right, that's a tangent constraint. To equal, we covered in the square to make those sides equal, and then I forced one into a dimension, which forced the other sides into their dimensions. And by virtue of the horizontal and vertical constraints, force those sides to be all equal. Parallel. This is going to ensure two lines are parallel to each other. So if I have a line, but I also have this square, I can say I want to set up a parallel constraint between this line and this line. And now it forces those two lines parallel. You can see the constraint is indicated by these icons. And again, over here for tangent, you'll see the tangent icon as well. So let's see. Wow, how would this be useful to you? And I'm going to mix in the description of, or the discussion of construction lines. Let's say you wanted to make a marquee of light bulbs, right? Like an old, like a movie marquee with a bunch of light bulbs and they turn on and off intermittently and kind of make it look like the lights are moving. So let's say you wanted to make one of those marquees. I'm going to just kind of maybe walk through just the logical thought process, and I'm not even saying that my thought process is a good one, but I'm just kind of started thinking about how would you use this in real life. So here we have the line tangential to the circle. I can still keep the angle and so forth, but you know what? I'm going to say, okay, I'm going to get as close as I can, but I'm a little off today, so I didn't get it quite right. So then let me add a constraint to that. We're going to add the horizontal vertical constraint. All right, added that to the line. I selected the line first, and the tool. Somebody can remember going the other way. So that forces this line horizontal. We already created our tangent. So this is the top of my marquee bar, let's say. So here I want to make sure that all of the lights that I create, or that I did add in my design, are all aligned to the same line. And in this case, that's what we have here. So let me see if I can try to copy this. All right, there's that. And more. I think that was working, maybe not. I guess not. All right, so here I have another light bulb. I copied it from the first one, or what is intended to be the design of the light bulb. And then I can add a constraint, tangent constraint, between that object and that light. And I can also believe I'm going to just experiment here and see if the tangent constraint allows me to connect these two circles. It may not. That's okay. It doesn't. Oh, it does. I think that worked. So now these two circles are tangent to each other. So they're not going to cross or overlap each other. But no matter where I take one, the other one is going to stick to it like glue. Oops, where'd it go? Something freaky deaky just happened there. I don't know what it was. All right, and then Control C, Control V. There's another copy. I'm going to drop that there. Click OK. Tangent between this circle and this line. Tangent between this circle and this circle. And oh wow, it's a little bit bigger. How did that happen? Tangent between these two. Oh, it's forced. It's scaling the circle to meet the other circle. So I'm not sure how to get around that. I don't have that kind of expertise. So I'm just going to grip. We'll do that. So, wow, that's a real tough. Okay, so now I understand. I'm starting to understand why you want to have things constrained. So what I'm going to do is I want to constrain this line now. So even though it's horizontal, it can still move up and down, which is kind of messing up my ability to scale these objects. So I'm going to create a coincident between, and I need an actual item. I can't go to any just grid item. I have to actually go to an anchorable item. In this case, the midpoint is the anchorable item. So I click on that one, click on that one. All right, so now you'll notice that that line has become black now. The highlighted, it's bluish, but it is black, which means it is constrained. It will not move. So then I can go back and start to do things like, okay, moving this. Why is it doing that so weird? Oh, because I guess I'm jumping around with the mouse. Huh. Oh, okay. Here's what I'm going to do. I'm actually going to use the move tool. Oh, and I know what else I can do. I can make a constraint to make them equal. All right. So I move that into place. Tangent between these two circles. And now to combat what I was fighting against there, I'm going to try to use the equal constraint to make sure that that is equal to that. I didn't get an error, so it didn't bark at me. And I want to make sure that this is equal to this. I think it worked. I see the equal in addition to the tangent. I'm hoping that that worked. So the idea here is I can continue to make a line of these circles and be confident that they're aligned with each other, that they're the same size, and no matter how I resize the overall project, that they will always kind of behave the same, which is that is to say that they will always be adjacent to each other and touching but not overlapping. All right. So equal, we demonstrated a couple different times, making those circles equal to each other to ensure that they are the same size. And the square that we wanted to, the rectangle, we wanted to make sure it stayed square, and we did that by making sure two sides were equal to each other. Two sides were equal to each other, and then one side was actually dimensioned, which forced it to be, it was the same side, the same dimension, the other side, which forced it to be square. It's a little, I said it in a confusing way, but believe me, that's what happened. All right, parallel lines, we talked about this, so imagine we're going to make these lights, continue on this string of lights, and then it's going to go downward, and then it's going to go through a bottom part, and then come back up again. So we could do something like, okay, create another line. And I'm going to create that line here and here. And I don't know if you notice this, when I'm creating lines, Fusion 360 has UI that once I click the second, I can end it by just kind of passing over this little green confirmation button. That'll end the line creation aspect or phase, if you will, and I can start to tweak it. You'll also notice that there's a degree, an angle, and a measurement associated with these. And I believe you can tab between the two. You can tab between the two. So if you want to change the angle and not really the dimension, or the length, or vice versa, you want to change the length and not necessarily the angle, you can kind of tab between those. I'm just going to take what they've given me here and click that little green button, which finalizes my action. And so I just wanted to demonstrate that in case I wasn't being clear and it was glossing over. Sometimes I can do that. So now we have a line that's parallel to this line. So we know it's not going to be off kilter. It's not going to slightly drift up or down. It actually is the same length just by virtue of how I drew it. But I can ensure that they are the same length by using the equal constraint and clicking both lines. And now those two lines will be equal no matter what. And then I can continue my, let's see if I can grab all these. I don't know if you noticed what I just did there. I don't know how often this is talked about. I think I must be, I'm not sure where I got it from. But left click and drag group selection is different than right click and drag, or that's left click and drag. And this is right click and drag. Now you'll notice one is yellow and has a dashed line around the bounding box. The other one has a solid line and is orange inside. And the way those behave is if I use the right click and drag, it selects just the objects that are fully covered by my selection. If I right click and drag, oops, that's something I need to do. You're still left mouse clicking, by the way. You're just dragging to the right or left. In this case, we're going to drag to the left. And only the objects touching, anything touching my bounding box will get selected. So you'll notice that that line is selected. If I do it this way, both those lines are selected. But if I'm going this way, neither of those lines are selected because you have to have everything that you want selected within the bounding box for that particular selection. So that's a little bit of a pro tip. If you just want to grab, those, you want to grab everything associated to an object, you can left click and left drag, or you can left click and right drag and only grab the thing fully encapsulated. All right, so now you can imagine I can grab these guys. Let's try this. Go in sketch mode. Move copy. There we go. Now I can run these down here. Let's say they're going to go on the top. Click OK. And now I can say, it looks like that these were retained. That's in between the circles. That is to say, these tangential constraints were retained, connecting these circles together. But the ones connecting them to the line above it have not been retained. You'll notice those are the ones connecting the circles. Those are the ones connecting to the line, and those are all missing in this scenario. So I'm going to add a couple of constraints. Tangential constraint for this one, and for this one. And so now you can kind of see the ideas. I could build these lights out around this, and that would be my design. Maybe I want to see holes for the lights, or do a laser cutting of some kind of facade for the lights, or what have you. But that's the idea. All right, let's go ahead and finish that sketch. Look at our piece. So I start a new one. And for this one, let's take a look at, so we did parallel, perpendicular. Okay, so I want to attach this line to this box, and I want to make sure once I attach it, it's not just attached to the box, but it is perfectly right angles to the box. So, you could say, okay, logic says I will just make this point coincident with this line, thusly attaching it. So let me try that. The point, that line, okay, boom, now it's there. And then I'm thinking, well, man, that looks a little off. Maybe I want to change it a little bit. So I'm try to pull it over here and try to pull it over here. But you'll notice when I get it exactly vertical, it actually shows me the constraint icon. So if I let go right now, it applies that constraint automatically. And now, even though I can still move this line back and forth on that ray, I cannot change the angle. So before moving this dot, would change the angle as it was attached to the line. Excuse me. And now I want to make sure that I exactly bisect this line edge. So I can go to constraints and find the midpoint constraint. Constrains a pointer object to the midpoint of another object. So I'm going to go ahead and select that. Just select that line as one object, and this ray is a line to the other. And what's it saying? Let me try this. It's saying that, I guess it's because it has this vertical constraint. So let me back up. There's our line again. So let's say I did not put the vertical constraint on. I could, but that was a midpoint. Okay, I'm confusing myself now, but let's try midpoint again. Here's midpoint. Here's a line. And it set the midpoint there, but a little unexpected behavior. I'm not quite sure what happened this thing. There it is. Interesting. Somehow defaulted to a horizontal constraint. All right, so here we are. Here's my line. What is that? Delete that. All right. Should be able to do a midpoint here. Here's my midpoint. There it is, midpoint. And I want to constrain that dot in the midpoint of this line. Okay. Now it's midpoint, so my point of showing you that is it doesn't have to be exactly plumb or perpendicular to the square there to still be a midpoint, right? I mean, it can always be in the middle, but you can change the angle. So there's still a chance that I could potentially not have this be where it needs to be. You'll notice nothing else is constrained on the sketch, so now it has all this behavior as well, which is unintended. So let's do. All right, so there's the vertical constraint, there's the midpoint constraint, so we've effectively bisected this edge and come out at a 90-degree angle. Now we can remove those constraints. Well, I'll leave the midpoint, but we could also do something like a perpendicular, which ensures that these two lines are always at 90-degree angles to each other. And that ensures the line will be straight up and down because it's derived from a line that is completely horizontal, and we're saying we want you to be 90 degrees to that line. All right, what else we got? We've got fix and unfix. This allows me to set a point to any other point anywhere, just kind of like a one-to-one. There's no kind of overall rules or guiding guidelines around it. It's just point to point. So excuse me for a second. And I can demonstrate that by taking, let's say, the point of the edge of this rectangle, maybe trying to apply it to this one over here. So let's see if that will even work. If I can get a point from this object. Yeah, there it is. So let me, we're going to do this here. I want to fix, trying to think this through. I want to fix. Yeah, no, I'm sorry. It only allows me to fix the thing I'm clicking on. So it fixed that point right there to where it's at, regardless of where it's at, because it didn't need any other anchor point. So then you see those two lines become black because now those are constrained, fully constrained. They can't be moved, scaled, or rotated. But you'll notice that the lower left-hand portion of the object is not fully constrained, and I can demonstrate that by grabbing the lower left-hand corner and scaling and moving that all around. Now, this top line won't move. It'll scale because this side is not constrained. Only this point's constrained. And this is the same for this side as well. So it can scale around, but it has to retain those qualities of the constraints that have been placed upon them. Even if I invert it, it still is respecting the constraints. It's a little bit different. It's a little bit different than this, but it's still respecting the constraints. All right, midpoint we talked about. So concentric. So going back to our light example, I think it's a good example. I might use again. These might be the outer dimensions of, say, the light bulbs themselves, but you actually want to drill a hole that's smaller, like the base of the bulb, not the big round part of the bulb. So in this case, we could use a concentric constraint, whereas, let's say I create a new circle, and I know that my light bulb is, we're going to call it 30 millimeters large, right? So there I have my potential light bulb. I'm going to use a dimensioning tool by clicking D. Click on the edge of the circle, and then actually type in here 30, I think that's what I said, 30 millimeters. So 30 is the actual base of the bulb. Let me just drag this over and see how this looks. Oops. Back to the select tool. That's a little too big. I want to actually make it a little bit smaller. So I'm going to double click the dimension that I've set for this, and I'm going to drop it down to 20 millimeters. Drag it over. And so this would be, the laser cut hole that allows the bulb to actually screw into the socket, or the CNC, the hole the CNC machine is going to make. What I can do is, okay, so I've got that kind of placed like I thought it was close, but you can see my human error, it's not quite centered. So again, we can use something like constraints, sketch constraint of concentric. And I'll just click it in this drop down so you can see here as well. This constrains two or more arcs, circles, or ellipses to the same center point. So I'm going to go ahead and select that. And select the outer circle and then the inner circle. And it ensures that it's concentric or equally distant from the outer edge to the inner edge. And so that could potentially be my actual the hole that I used to manufacture to allow me to screw the light bulb into the socket of my marquee that we're building. All right. Moving on to more sketch constraints. Collinear. So this constrains two or more objects if they share a common line. This could be a line and a rectangle where the line and one edge of the rectangle lie along the same line. And again, the line is that indefinite ray, going indefinitely in either direction. It's not just the line we're drawing on the screen. It's the concept of the line that is drawn between 2 points. So collinear, let's demonstrate this. Mine's a little bit less intuitive for me here. I guess it's, so we have this line here, and if we wanted to align, and that's the top of our marquee, which is the bottom of our bulbs, aligned to that guideline. Maybe we want to align, let's see here. There's going to be an electrical box buried inside this marquee, kind of like this box represents here, but we're going to create that representation of that electrical box. But I want everything attached to the top piece of wood of this marquee light. I don't want anything attached to the bottom. It's the way they mount, let's say. Probably more in reverse, but just say for purposes of this argument. So I want to put my junction box down in here somewhere. This will allow me to connect my wires. But I want to ensure that it's aligned to this same guideline that I have up here. So I can choose the collinear constraint, choose this line here, and this line here, and it aligns my electrical box to the bottom of this guide point, or the wood that holds the light bulbs and what have you. So that is an example of the collinear. Again, just to help drive this point home, the line, the concept of the line moves beyond the line we've actually drawn here in the field. So this can move on out and out, and continue out here even off of the visible line. And getting towards the end of the list here, symmetry. Constrains two or more objects if they are symmetrical, identical to each other in relation to a common axis. So we want to make sure that, let's see here. Okay, so I accidentally misaligned my three light bulbs. And I wanted to actually be aligned with these ones down here. So it will allow me to do it. Symmetry. So those three. Well, you know what? I'm not super sure about symmetry. I'm actually going to kind of punt on symmetry, so I just don't understand it that well. It's not, I'm kind of trying to execute like the pattern tool, but I don't think that's happening for me right now. All right, curvature. Let's try that one. I think that's a little bit more doable. So I'm just going to make a curve here. And I'm going to say that I want to have a curvature constraint between this object and this object. Can I do it? Okay, constrains two or more objects to create a smooth, continuous curvature between them. I'm totally experimenting with this one. I have no idea how this is going to work. So that way, nothing else is clicking. Yep, right. Well, did pretty good until we got down to the last two until I didn't really practice that much. So that is a large part of the constraints and how they're used. Now, I also want to talk a little bit about construction lines because they are kind of key to some of this activity that we've been doing here, especially when you're aligning to lines or have guidelines that you want to set other objects in relation to. there is the concept of construction lines, construction objects, which I don't utilize enough, but I'm starting to become a little bit more familiar with them. I utilize them more a little bit in the 3D space, but I also just want to demonstrate their usefulness overall. And I think I'm starting to use them more, and I'm understanding why they exist and how I could not have lived without them before. So you notice over here in the sketch palette, which will pop up when we're in sketch mode, if we're still in. A couple of earlier, I don't know if I mentioned that earlier tonight, but you'll see two things. When you go into sketch mode, you have to start and end the sketch mode. And to end the sketch mode, once you're in it, you'll see a big finish sketch button, big green button over here in the upper right-hand corner, or this finish sketch button here that's part of the sketch palette pop out. And so at the top of this list is something called construction. And if you select something and then click construction, I just did that to this curved line here. You can see it becomes a dotted line. And these act and behave the same way as lines that you would create, or if I took this circle and I click construction, you put them on the screen and then manipulate them the exact same way that we've been doing so far. But once you identify them as construction lines, they no longer have an active part in the manufacture of your objects. What they're there for is simply for guides. Curve guides, measurement guides, alignment guides, allowing you to take a 2D image and extrapolate it into a third dimension, right? You have to, what is that third dimension? Where is that third dimension at? These are things that you can kind of describe with construction lines, construction planes, and other construction elements. Again, they are part of the design, and we put them on the screen just like any other element. But once we identify it as a construction element, it no longer is part of the core design. It's simply there for you to measure against or allow you to somehow assist you in the design and layout of your design. All right, so that being said, let's say I wanted to make a, how can I say this? I wanted to make a cone the hard way. And when I say that, I mean like you can go over here and let me drop out of sketch. I can go to create. And I thought there was a cone. Was there a cone? All right, well, my example is probably not as apt, but let's say I was trying to say let's create a cone the hard way, but let's just say we wanted to create a cone. And a cone is, a cylinder that's bigger on one side than it is on the other, right? That is to say, if I had a cylinder and it was, 1 millimeter on one side and 100 millimeters on the other, that basically creates a cone shape. It's round, but it flares from one dimension to the other. We can do things like that with construction lines, or we can kind of define where that floor is and where the ceiling is in something, whereas we really can't define that with sketch objects so much. So let me just give you an example. I'm just going to actually get rid of a bunch of this stuff because it's getting a little messy. And we're going to create a new sketch on the XY plane, looking down upon it. So it says top view on our view cube. And I'm going to create a circle. It's going to be a midpoint circle starting at our midpoint of our design and extending out 50 millimeter radius. So I think it's 100 millimeter diameter. What is that? Vector. I'm going to finish sketch. Now, I can extrude this object and pull it, into the third dimension, but it's going to be uniform. This is not going to vary at all. It's going to be a straight wall. The exact dimension of the object I started with will be the exact dimension of the object I end with at the end of each of that cylinder. That is to say, the circle on one end of the cylinder is going to be the same size as the circle on the other end, no matter how long you make the cylinder. Whether it's this long or this long or longer. I can, so I really can't make I can't tell it, hey, I want a big circle here and I want a small circle at the end. Just keep tapering until you get to the end of that small circle. There's no function that does that as part of the sketch. So what I basically have to do is create two sketches, one with the first circle and one with the smaller, excuse me, the larger circle, one with the smaller circle at different heights. And to do that, I would create a new plane that I could sketch upon, because we're sketching upon the XY plane right now, but I would need a new plane that's not the XY plane to sketch upon. So this would be where we would use construction object. And so if I click on construct over here, oops, that's the extrude, and on the construct menu up on the top toolbar, click that, and we're going to create an offset plane. So it's a construction object, and it's going to be offset. It can be offset off the plane itself down here, or the circle that's sitting upon that plane. So let's go ahead and just click the circle. And I can then tell it how far from that initial plane do I want to create this new plane that I'm creating. And so I can say, in this case, 150 millimeters, click OK. And now this is not part of my design, but there's a phantom plane that's sitting up here 150 millimeters above this bottom plane that I can then now start to treat as a new plane. But this is not an object in my design. It won't be printed, it won't be 3D printed, it won't be CNC milled, it won't be laser cut. This is not something that exists other than as a guide element in my design. It's not actually part of the design. And so now I have this 150 millimeter, this new construction plane at 150 millimeter altitude above the old one, of the beginning plane. And so now I can go ahead and sketch a new object on this plane. So I'll create a sketch. I'll put it on that plane. Actually, the plane was already selected, so it auto-selected and put me into that. So let me back out of that. That wasn't as clear as I had hoped it would be. See, I have it selected already. If I click off of it, oops, sorry, I'm kind of repeating myself. This is the new plane that I have. So if I want to click off, I'm not actually, and I can turn it on or turn it off to view it. But let's just, for now, we'll leave it on, and I'm going to create a new sketch. And I'm going to actually sketch upon this new construction plane. So I'm actually going to click it. And so now that pops up there. It's kind of showing us what's below, because construction plane is not a solid. It's not a body. It's showing us right down from the top view down the previous circle that we made. So now we're going to make a smaller circle. But you know what? We're not going to put it on the same midpoint. We'll put it over here. And I'm going to click Finish Sketch. All right, so now 150 millimeters above this plane, this new object is sketched upon that phantom construction plane. It's like this first plane, but it's 150 millimeters up. And so now I can do things instead of that uniform extrude that would just extrude this circle upward. I can do something like a loft, which will allow me to move from one object to another at different altitudes, which will then create a new body that's shaped to accommodate that altitude change and the size change between those two layers or two planes. So here we can start, creating novel objects. And this, I wouldn't have been able to do this, I don't think, without a construction plane. Maybe there are other ways to script it or what have you, but without the creation of a construction plane at a different altitude, I would have had nothing to sketch against. Maybe I could have created a square that was 150 millimeters and then try to create a new sketch that was on that square's face or something, and then turn the square off so only the face of that square was there, and they have to use circles. There might be other complicated ways to do it, but that is one way to use construction line. Now here's another way. Let's say we wanted to draw a line from the midpoint of the initial circle that we had through the midpoint of the new circle that we created. Now this is kind of an interesting challenge. I'm going to click OK and create that object. Now I'm going to go back to top. And I don't do this all the time, but I'm going to do this to show this. I'm going to go to display settings. And I'm going to change the visual style to wireframe. And that allows me to see both the top and bottom circles. And I want to do that for a reason. Because if I want to, say, draw a line through the center point of the initial circle and the center point of the second circle, that line is going to be diagonal, right? It's not going to be straight up and down. This is offset, so it's going to be kind of wonky. So what I can do is, I don't want to add a line to my design, but I want to be able to position some of my next design elements from that ray that's created through those center points. So let me create a line. Let me think here for a moment. I'm going to create an axis through 2 points. And that's going to be the base point here. And this midpoint there. And you'll see now it's created that axis. Let's see the axis that goes through those two, that ray that goes through those 2 points. And I'm going to click OK. And it looks like, did I already do this construction line? Oh yes, going to create the construction line through 2 points. So that is a construction line that I can then go ahead now and hang something else off of. Let's say I wanted to create a new circle. I want to create a sketch. I want it to be on that plane, but I really want it to be a circle. Let's see if I can hold this. I guess I can't. Let me try new sketch. Let me try this. Let me create an object. Let's say I want to put a sphere on the XY plane. Let me put it, I can do this like this. Hold on, I might give it up on this. Let me see if another construction objects I can make here. Plane tangent to face of point. So now I've created a plane that was tangent to the object, I guess the face, this face, and the point that I selected. So I'm going to let you just start to be able to, I'm clearly not the most adept at utilizing construction, all the aspects of construction lines. Going to let you, whereas you might not have had a center point, you might not have had a corner point, you might not have had a line to align something to. You can think, because it's not part of your design, you can lay in these construction lines, you can lay in these construction planes, and lay in these other construction elements that you can then go ahead and attach or sketch against. Like in this case, now here's a completely new plane that if I wanted to sketch against, because it has that angle, and I can then now say create sketch on this plane, and what I want to create is some text. I'm going to put it here, and there's my sample text. Let's see, Curtis, and you'll see that Curtis is actually on the, well, make myself visible, is on the plane that we created. the construction plane. Now the Curtis is part of, it's not a construction element, it's real. I could extrude the Curtis and it would be, in fact, let's take a look at that. Let's finish sketch. I'm going to extrude Curtis in this direction. And so what you end up with is Curtis that is backed up against the tangent plane that was created from this line, from the top point of the line and the angle of this object. So can't say I totally understand all of it, but you know, you can start to see how you can use these construction elements to help position and align and create the designs that you want to create. Alrighty. So that, I think, has taken us through a number of the constraints, the utilization of construction lines. We talked about using the S key to pull up the design shortcuts or search menu, to which you can then go ahead and start entering things like text. And then it pulls up the text menu for you. Or you can do things like extrude. And then it pulls up the extrude command for you. You can just get straight into extruding or cutting, depending on what your object is doing. And what else can we talk about? Let me just go here to I think I had a handy dandy document open. Then again, maybe not. I'm just checking it right now. Give me just a moment. It's opening. I'm going to take a sip of my beverage. We talked about the offset tool. No, we talked about the offset constraint, but I don't think we talked about the offset tool. So let me just show that. Very similar. This is one is an action, one is kind of constraint. But in the instance of this object here, and what I'm going to do is I'm going to change the view settings again. So now that we got all of the lines and holes that we wanted, I'm going to go back to a shaded view style. You can see how that Curtis aligns right along the edge of that. That's kind of what we created there. So if we go back, so here's the timeline that was created from our project. And this is a combination of sketches and features that were applied throughout this discussion. And what we can do is we can go back and we can actually tweak designs along the timeline, and it will actually ripple and propagate those changes through the final project. So if I double click on this first sketch, it shows us this circle here. Excuse me. And let's say I wanted more than just this circle. So we had the constraint earlier where I created a smaller circle and then I concentric constrained it to the circle outside of it. But we also have the ability to actually just create a new circle right off the bat. And for that, we can use the offset tool. And it's over here under modify. It's also the O key, or if we were using our search, we can hit S and then start to type in off, and you'll see offset. You click that, we can click this line, and now we can create a second line that's offset by a certain dimension from the first line. And these can cascade. You can do multiples of these. So I can say 20 degrees and say 20 millimeters, and then oops, back to modify, offset again. And this is going to be 40 millimeters, and so forth. So let's finish that sketch. So even though those sketch items changed, it didn't change the final design. So they didn't do anything with those added circles I created. If you look at them, there they are. Turn them back on. So they really don't have any meaning yet. I mean, I could go back and maybe create an extrude for one of these. Let's say I wanted to extrude this outer edge. I can go back and do that, and then let's say I want to extrude that as part of it. And so now our body looks like this. So we've added these new dimensions that we can then add other features around. You can grab, there's a pointer, timeline pointer, and actually pull this back and forth to the timeline to kind of deactivate and activate things along the timeline. You can go back and right click to delete, rename, edit, and change things in the timeline as you see fit. And yes, that is the offset tool. We talked about construction objects, construction lines, construction planes. Something else we'll talk about, a little bit more of an intermediate concept, is the importing 2D, like the XF files, what have you. But you know what I'm going to do? I'm actually going to do something else before that. So let me just select all these sketches and delete them. I'm going to get rid of these construction objects and everything else related to that. And finally, I'm going to get rid of these bodies that were created through our design process. There's also a couple other control elements on the view cube here. There's rotate left and right. There's like a home button. This is the 3/4 kind of view. You can click on the various surfaces to go directly to them, or the arrows to rotate around them. What else can I show you? Right clicking also pulls up this menu, which is a part of this icon here, this drop down icon. And I've talked about again, kind of resetting the view cube. So if you're looking down upon the XY plane, that is the red-Y plane, sorry, the red-green plane, then you're really looking at the top of the object. And so the Z plane, the Z axis is coming out at you, 90 degrees from these axes here. And you can reset that view to top so that when you're looking at that, you right click and reset this current view as to top to make sure that you ensure that you're looking at the top of the object. And that just helps with alignment if you are going to put it on a CNC machine or a 3D printer or what have you. The XF. Okay, so we can insert. We can use the insert tool, which is part of the design tool set over here on the end of the bar. We have this, and you can insert a DXF. You tell it what plane you want to insert it onto. So that's the flat plane looking down upon this. And so I click that. Let's see here. Okay, so it wants to know what file. So I click on this little folder. It pulls up a file selection menu. Let's see what I have. Yeah, I don't think for some reason the system doesn't have some of my core files on it. So let me just quickly, we'll do a quick search for, let's do a robot DXF. Here we go. I'm going to go here. Nope, it's not one. Oh, it's going to charge me for it. Let's try this. Try Thingiverse. Okay, I typed it wrong. Dang it. Thingiverse. What? That's not what I want. That's what's going on here. Thingiverse. DXF. I'll take any at this point. Let's look at this. Look at a simple shape. There we go, hobbyists. So download that. Should be in my downloads folder now. So we will click the file folder, browse to downloads. There's pi.txf already there waiting for me. Blind, I didn't see it. And there it is. Click OK. And so we've taken the DXF and we've imported it straight into our workspace. We can now, do whatever we want with it. We can do something like maybe we want to extrude it. Throw that on the 3D printer and print that out for a party or a pie party or what have you. That is a real quick way to just show how you would import a DXF or other type of CAD file. Then insert in the toolbar, insert DXF, or you could also insert SVG. And that allows you to kind of quickly get up and running from a 2D sketch and take that into the third dimension if you so desire. That or apply 2D CNC tool paths to it. Okay, what else do we got for you here? So a similar kind of exercise. We'll go to Thingiverse. We will do a search on statue. All right, here's this owl that's kind of cool. Let's download that bad boy in files. And it's an STL. So this is straight up 3D printed file, 3D file for 3D printing. Let's go ahead and save it down. It's downloading. So let's imagine that our 3D printer is too small to print this object. We have to split it for some reason or another. We have to split it into two objects. Sorry, you can't see what I browsed there. I actually picked up the owl STL off of Thingiverse. And I'm going to import that in just a moment. All right. So we'll leave our little pi symbol there, but we'll also go to Insert, and we're going to insert mesh. And here's the owl. So it looks like our top is actually our bottom. So I'm going to get rid of pi. Sorry, pi. That's too good to me. Oops, let me place the owl first. I'm going to right click and delete pi. And then I'm going to delete the body we created from the pi sketch, which leaves us with just the owl. If we go to the top, it clearly looks like we're looking at the bottom. So I'm going to try to reset the current view as let's go home and see what happens there. Okay, so that is not those fronts. All right, well, it's upside down. That's just the way it's going to be, I guess. All right, so we want to split this object. So there's a couple different ways to do it. Well, there's a way to do this, and I'm aware of. One, there's a kind of a hidden tool set. So in Fusion 360, we have a number of workspaces: the drawing, manufacture, simulation, animation, render, and design workspaces. And each workspace has a number of tool sets that goes along with it. In the design workspace, we have the solid tool set, we have the surface tool set, we have the sheet metal tool set, and then some other assorted diagnostic and measurement tools in the tools. And each workspace has kind of its own set of tools for that workspace. And you'll see the toolbar change as we move through the different types of workspaces again up here. But what we can do is we can right click on this object and we can select edit. And I don't know if you noticed again, but this tool set has changed yet again up top. And this is not something that we can click into directly. This is by virtue of right-clicking on the mesh object, and then it pulls up this specific mesh menu. I may also have beta features turned on, so if this is not immediately apparent, then you might need to look at those places you can turn on beta or future features that are being tested and they're gathering information on. And so that might be represented here, maybe it's not why it's represented in the UI clearly as well. I can't say for sure, but I just want to kind of make that distinction. And with some interesting tools here, like with this owl, if I wanted to split it in two, I could go to this plane cut tool and select this body as the item, and then I can select a plane that I want to cut against, and I'll say that one. And then I can pull this slider back and forth and cut the object. But what I'm going to do is it's in a trim mode right now, so depending on how I pull it, it will reduce the object that we currently have. But what I'm going to do is I'm going to do split body. And so now what happens is it allows me a midpoint that I can still manipulate backwards and forwards, but it's actually splitting the body. So if I run it right about the middle of the beak here, it's kind of jumping because of my zoom. So that's pretty close. It's not right down the middle of the beak, but it's pretty close, I think. I know. There we go. It's kind of slicing through it here, but so I can go ahead and click OK. Now what you'll notice is there's two bodies that are created. There's mesh body 1 and mesh body 2. And if we zoom out, you can see that these are two separate elements that we can then go ahead and print individually and what have you. So you'll notice even though, so we cut it, right? So there's a hollow on the inside that we can then apply some repair tools to. So we can say, okay, those are the two pieces, we split them up. That's what I'm going to do. Let's say I want to make a closed mesh. So it'll take this kind of open mesh and close it. So let me make closed mesh. Select that one. The rebuild mode is standard. I'll click OK. And now what you'll notice is that object is hollow. This one now has an edge that's been built to kind of close off that inside edge in here. You can see that there's an actual edge. You're seeing the reflection of my tool on that actual edge. So that's the way to split bodies, mesh bodies. You pull them in as STLs. The only way to get them is Thingiverse. You want to make some kind of tweak or modification. Or if you want to resize, split the object up so you can fit it on your bed or whatever your challenge is, you right click, insert the mesh, much like we inserted the DXF. Once the mesh is on the workspace, you can right click on the mesh itself, click edit, and then that will pull up the mesh tool set that you'll see here represented on my screen. All right, I'm going to show maybe one or two other things. And I think that's going to be about it for tonight. So what I'm going to cover next is basically taking an existing design and placing it in this environment for you to model against or model after. So let me Get rid of some of these here. And what we're going to do is, oops, finish mesh. So we're on now. What we're going to do here is we're going to use the insert command again, and this time we're going to insert a canvas object. It's going to ask me from where I want to insert this. It's going to be from my computer. I have these locally, and we'll do something kind of simple. So it's queuing me here to ask me what plane do I want to place this canvas upon. I'm going to place it on this plane. Oh, there it is. That's fine. Okay. So I've taken this image just right off my hard drive, and I've placed it in the workspace on one of the planes. So what I can do now is I can effectively use this image to model something that I want to model either in 2D or 3D. So just kind of follow me here for a second. I'm going to create a sketch. Sketch is going to be upon this plane that we're looking down at. I'm going to reset the current view as top, and then I'm going to, how am I going to do this? Okay, I'm going to choose circle. Okay, so I've got 3 circles. And I'm going to create rectangle. And this time, I don't want single point, I don't want 2 point, I want a 3-point rectangle. Let's see if I can get this. So kind of approximating the bars between molecules. And now I'm in CAD mode, so I'm going to do some CAD-like stuff. I'll use the trim key and the T key. And I'm going to trim some of these extra edges away because I have some overlap of the squares and the circles. Oh, a little bit of a weird edge here. I think what I'm going to do is create a new line. We could pass through there, and then I'm going to trim these extra components. From the sketch. And now, if I select and now I've created a 2D object based on that canvas I placed in the background for me to sketch against. So now I've taken the visual, the image, or the bitmap image, and created a vector-based image based on the parameters of that object. And so that is Canvas, using Canvas to help inform your designs. And my final is patterns. So let's say we want to do, say, some patterns of this object. So I'm going to look down on the top. Oops. And I'm going to place this object right about here. And so what I want to do is pattern. I want to make a rectangular pattern. guess it won't let me do that. So now I'm going to try it in sketch mode. I'm trying to do it without sketch mode. I'm going to try it in sketch mode. Sketch upon that surface. And here we want to create a circular pattern. And it won't let me do that there. Maybe what I'm going to try to do now is I'm going to extrude this object. Give it 2 millimeters, so now it's an actual body. So maybe I can now pattern the body. There we go. And I can show the axes. Axes are typically hidden, but I can show them. And then it's asking me for which axis do I want to revolve around. So I can select this one here. And you'll notice that if you increase the number, that will start to pattern these around that center axis in a circular pattern. Okay. Oops, didn't like that for some reason. But that's a quick example of the patterning tool. So that's about it for tonight. Thank you very much for tuning in and checking out the live stream. Hopefully you got some answers to your questions. And hope you can make it out to Hacker Lab sometime soon. Check out our virtual classes and various seminars and small business coaching that's offered. And if you have any questions, you can give me a holler at Hacker Lab. You can reach me through Hacker Lab. So thank you, everybody. Have a great night. Take care.